Nothing failed. The same tenant, the same policy set, the same confirmations we've relied on for months. Retention labels applied, library versioning enabled, eDiscovery cases open, the unified audit log recording. Every dashboard green, every report reconciled. Here's what actually happens. We ask one question, the system answers correctly, and we assume the meaning didn't move. Most people think stable outputs prove control, but stability can also hide drift. We're going to replay the exact scenario, same facts, same steps, and watch the behavior, not the color. We'll run this again. Let's define green, establish the baseline, and pin what success looks like. Environment baseline, what green looks like. One tenant, one scenario, no noise. SharePoint Online active with standard site collections for Teams, connected workspaces, and a few communication sites. OneDrive provisioned tenant-wide, default quotas intact. Teams in regular use for channel files and meeting artifacts. Microsoft Purview configured with data lifecycle management policies and auto-applied retention labels. Information protection present even if we're not stress testing encryption today. The audit signals first, unified audit log is on. We've validated the role and license preconditions, searched the recent 24-hour window, and seen expected verbs. File uploaded, file downloaded, file accessed, file modified, mail items accessed where appropriate. No gaps, no throttling errors. The outcome was correct, so we ran it again. Clean Compliance Manager shows our assessed controls mapped and scored. The score is steady week over week. No red items in our scoped baseline, a few improvements available, but none affecting retention or discovery for this tenant. The posture graph is flat. That's when we realized flatness might not equal certainty, only repetition. Secure score unchanged across the last 3 reviews. MFA enforced for admins, conditional access policies active, privileged identity management wrapping elevation. No alerts in Defender for cloud apps tied to SharePoint or OneDrive anomalous downloads. The perimeter looks contained, the logs were clean, the pattern wasn't. Retention configurations next. We have organization-wide retention policies scoped to SharePoint sites, OneDrive accounts, and Exchange mailboxes. The policies state retain then delete with defined durations. We also have auto-apply retention labels on libraries that match content queries. Preservation lock is not engaged for our test policies. This matters for reversibility but not for observation. eDiscovery standard case exists with custodians added and legal holds available but not yet applied. We keep holds optional to observe default lifecycle first. Policy distribution completed more than 7 days ago. Status shows on success. No pending propagation to explain variants later. Library level versioning settings are visible. Major versions enabled. For sites where intelligent versioning is in play, the UI reports the automatic 500 version logic. We note the rule. First 30 days preserve versions aggressively. Thinning increases after day 30. And retention, if applied, overrides trimming. We document the cap and the thinning cadence because version history will become our first instrument. The numbers look normal, the implications don't. Ground truth sources are pinned, library settings pages for versioning and content approval states. Preservation, hold library, PHL, URLs recorded for each target site. We confirm they exist only on first edit/delete under retention. Storage metrics for the libraries in question to reconcile size deltas with version churn. Unified audit log queries saved to capture edit velocity versus committed version creation. Success artifacts are collected. Compliance Manager export showing control implementations. Secure score history report. Purview policy list with scopes, actions, and status. eDiscovery case metadata, custodians, queries, no holds yet. UL export with a 48-hour slice to catch burst behavior. All reports show green, no variance. Dashboard stable. We acknowledge the constraint window, up to 7 days for policy propagation. Background jobs for expiration run on cadence. Recycle bin holds for 93 days. And version caps at 500 by automatic logic. We accept those timers as the environment's clock. We will not force clocks. We will observe them. Now, what does green mean operationally? A labeled document should persist until the retention period expires regardless of user deletes. A library with major versioning enabled should grow version counts in proportion to meaningful edit events subject to caps and intelligent thinning. A site under retention should populate its PHL upon first relevant edit or deletion, preserving originals invisibly. eDiscovery queries with stable KQL across the same custodians should reflect corpus growth or shrinkage, not stay flat without cause. The audit log should reconcile action velocity to some footprint in versions, holds, or search counts even if delayed. We set acceptance criteria. Version velocity matches, within a reasonable band, the observed file modified cadence for Office documents in high-activity libraries. PHL footprint grows when user visible history shrinks due to user deletions during retention. eDiscovery result counts scale over time with new content, or we can explain scope filters that counter growth. Secure score and compliance manager stability is documented, but not used as sole evidence of control. We limit noise, no priority cleanup policies active. We don't want pre-governance deletion to mask behavior yet. No holds applied initially. Holds change precedence. We'll add them deliberately in later loops. No label changes mid-observation. Propagation delays confuse causality. No external tool intervention. Native behavior only. Everything is green. The outcome is correct, so we ran it again. In retrospect, green is a color, not a behavior. The tenant meets policy definitions. The signals are consistent. That consistency is our baseline and our trap. If the system keeps answering correctly, the only variable left is the question we think we asked. We're ready to press the loop. Loop 0, the perfect run. The same policy executed again. The outcome was correct. Labels applied successfully. The library reported major versions enabled. The PHL stayed dormant as expected because nothing had been deleted yet. Our eDiscovery case returned results that matched our test KQL exactly. The unified audit log stitched a clean sequence. Upload, open, modify, autosave, close. Nothing failed. So we ran it again. We chose one high-activity library in a Teams connected site. Office files with autosave on. Co-authoring allowed. We opened 6 documents, staggered edits, saved on each meaningful change. The version history window populated with neat increments. Version 3, version 4, version 5. Names and timestamps lined up against our audit events. The counts aligned. Back to purview. The retention label we auto-applied was visible in the file banner. The item level details confirmed. Retain for the configured duration, then delete. The policy state remained on success. That's when we realized our confirmation cadence was rehearsed. The system answered correctly, but we were still asking a beginner's question. We widened the run. Added 2 OneDrive accounts to observe personal site behavior under the same retention policy. Uploaded new content, edited, and then deleted 1 file in each account. The first deletion in each site created the preservation hold library behind the scenes. We verified with the URL. Copies existed there. The user recycle bins showed the deletions aging toward the 93-day threshold. Everything reconciled. Reports were satisfied. Compliance manager still green. Secure score unchanged. The dashboards didn't blink. We checked the eDiscovery case. We had a simple KQL, file name fragments, a sensitivity to author fields, and a date range for this week. The results returned the new files from the site and the OneDrive accounts. Counts aligned with uploads. Exports succeeded. Processing windows matched expectations. So we ran it again. We triggered concurrency. 3 editors opened the same document. Edits overlapped, comments flew, tracked changes collided, and autosave churned. The version history showed a compressed sequence, fewer than the total edit touches might imply, but still an acceptable step with the events we'd consider meaningful. We accepted the compression as expected consolidation from co-authoring. The UAL showed velocity spikes in file modified activity. Version numbers climbed, though not 1-to-1. We logged the ratio as close enough under load. We planted micro checks, picked a random file, rolled back to version 2, saved, and then restored the latest. The system preserved the intermediate state, then returned us to present. The labels persisted, the retention settings didn't flicker, the PHL didn't engage because we hadn't deleted anything. The behavior was consistent. We added a gentle stressor, moved a labeled file between libraries within the same site. The label traveled with it. The audit log captured the move. eDiscovery found it in the new location. The policy scope permitted it. The outcome was correct. We replayed discovery. Same KQL, same custodians, same scope. The counts were stable with small increases precisely where we added content. Exports matched counts. No partial indexing flags remain. Advanced indexing had nothing to add. Processing completed within the typical window. No alerts triggered, so we ran it again. We flipped the deletion switch, removed a labeled file from a library under retention. The user-facing library showed it gone. The first stage recycle bin held it, clock started. The PHL got a preserved copy. Version history for the preserved item showed the consolidated prior versions captured as one preserved artifact as designed in recent changes. We reconciled the sizes. Storage metrics increased predictably. Nothing unusual. We checked preconditions that usually break clean runs. Policy distribution age, over 7 days. Status, success. License coverage for audit, valid. Role assignments for eDiscovery, confirmed. Conditional access not interfering with our browser sessions, verified. We removed edge excuses before they could explain drift. There was none to explain. We compared version velocity to file modified volume in the UAL. The slope lines weren't identical, but they were parallel enough for day zero confidence. Co-authoring flattened version creation, and that was acceptable under an intelligent scheme. We noted it and moved on. We flipped to the human view. A project owner opened SharePoint, saw the label on their files, saw version history increments, and trusted the little shield. They could delete a file and see it go away. They could see it in PHL and Discovery. Legal could find it with the same KQL. Security could point at green scores. Everyone's expectations were met. That's when we realized the perfect run was a mirror. It reflected our question back at us. We asked, does it work? The system showed us working parts. We nodded. We needed to ask, what changed while it was working? We seeded the next observation. We bookmarked version counts for 5 frequently edited files. We saved the file modified velocity baseline for the same window. We captured the PHL size, zeroing it before deletes. We saved the eDiscovery execution timeline and result counts for the weekly query. We wanted to replay with sharper dials. One last pass. We created, edited, deleted, restored, and discovered a controlled set. Every subsystem responded as documented. Labels stuck. Versions grew, holds captured, discovery found, logs reconciled, nothing failed. So we ran it again, with the same facts, the same steps, and a new intention. Stop checking for correctness and start measuring behavior under repetition. That's when we realized the outcome was correct. The behavior had not been tested. The next loop would ask about creation itself. Loop 1. Statement of question. Creation. This time we're testing creation. The same tenant, the same policies, the same libraries. New question. When we create and edit at speed, does version history reflect the work, or does the system reinterpret the activity and store less than we expect? We scoped a busy library. Office files, autosave on, co-authoring allowed, editors distributed across time zones. We didn't change labels, retention, or site settings. We only changed the question. Creation under load. Expectation stated plainly. Edit volume should correlate with version growth. Not one-to-one, but proportional. Meaningful edits should persist as distinct versions for a reasonable window, then thin predictably. We accept intelligent versioning exists. We're not arguing with efficiency. We're verifying that history remains history while the work is still fresh. So we ran it again. We scheduled a burst, 12 files, 6 editors, 20-minute window. Each editor made 5 meaningful changes per document. Sections added, tables updated, formulas rewritten, tracked changes toggled to force material deltas. We logged file modified velocity in the unified audit log for the window. We pinned the starting version number for each file. We captured end-state version numbers and the timestamps. The outcome surprised quietly. Version counts looked flat against the spike. Edits happened. Content moved forward, but version numbers advanced far fewer steps than the audit suggested. Not zero, not broken, just flatter than the activity implied. We controlled for noise. We repeated with autosave off and manual saves on every meaningful change. Version counts rose, then plateaued mid-burst. We repeated with comments only. Comments produced fewer version increments as expected. We repeated with tracked changes forced. Slight improvement in version increments still below edit volume. We alternated single author and co-authoring sessions. Single author produced more versions than multi-author, but neither matched edit velocity. Now, this is important because versioning defines history. If the platform compresses creation aggressively, then the artifact pool we assume exists for retention, restoration, and discovery is smaller than our mental model. The policy didn't fail. The object changed. We paused and rephrased the question. Are we witnessing suppression, or are we witnessing intelligent consolidation that honors recent time windows differently than we remember? We collected one more dial, version expiration indicators, where automatic trimming applies. So we saw the never expires tag on the current version and schedule hints on older versions well past 30 days. Our burst was brand new, no trimming yet. Compression occurred at creation, not later thinning. So we ran it again, slower. Same editors, same documents. Save only after a paragraph level change. Wait 30 seconds between saves. Version counts rose more predictably, but still fewer than edits. The slope improved. The ratio remained below intuitive expectation. Expectation meets observation. We accept that intelligent versioning exists. We also accept that our policy promises depend on the number of preserved states, not the number of keystrokes. Creation became our first drift indicator, even while every control remained green. Loop 1. Evidence proving version suppression. We needed proof, not intuition, so we ran it again, this time with instruments up. First, library settings. Versioning settings snapshot taken before the burst. Major versions enabled, no minor versions. The tenant-wide intelligent versioning banner present, up to 500 versions per file. Thinning increases after 30 days. Current version never expires. Retention overrides trimming. We exported the setting state for the library and the site to file timestamped, then the unified audit log deltas. We executed saved queries for file modified and file accessed across the specific library URLs and document IDs bounded to the burst window. We extracted counts per document and computed velocity modification events per minute. No throttling errors, no delayed ingestion flags. The numbers were spiky as designed. The outcome was correct. Now we compared. For each file, we plotted UAL file modified counts versus version history increments. In single author sessions, the ratio settled around 2:1 or 3:1, 2 or 3 file modified events per version increment. In co-authoring sessions, the ratio widened 5, sometimes 6:1. We confirmed autosave's consolidation behavior. We didn't argue with it. We documented it. But here's where it gets interesting. We toggled autosave off, mandated manual saves after meaningful edits, and repeated. The ratio tightened but did not normalize to 1:1. Why? Because the platform still coalesces rapid sequential saves by the same author within a narrow window. The saving cadence matters. We measured windows, saves within roughly a handful of seconds compressed into one version. Wait 30 seconds, you're more likely to get distinct versions. We logged it, edge cases next, non-office files. We uploaded PDFs and images, modified metadata, replaced files with same name. Version behavior changed. Replacing files generated new versions reliably. Metadata edits sometimes did, sometimes didn't, depending on column type and library settings. Autosave didn't apply. The ratios collapsed toward 1:1 for replacements. We noted the distinction. Office co-authoring plus autosave is the compressive engine. Non-office replacements are blunt increments. We move to intelligent versioning nuance. The cap is 500. Trimming favors recent versions aggressively for the first 30 days, meaning it doesn't trim recent versions. Our burst was under 30 minutes old. No trimming. Yet our counts were already compressed relative to activity. Therefore, compression occurs at creation, not only by later thinning. That's the first proof point. Retention override nuance. Retention labels and policies that apply to items prevent deletion of retained versions until the period ends. We applied a retain then delete label to the burst files and repeated the test. Same compression at creation. The label did not change consolidation, it only prevents trimming later. The number of preserved states still reflected the consolidation logic. That's the second proof point. Co-authoring merges. We constructed a conflict scenario, simultaneous edits to the same paragraph by 2 authors, then resolution. The platform produced a single version with merged content and embedded track changes. Metadata, not 2 separate versions, capturing each author's intermediate state. The UAL recorded multiple file-modified events close together. Version history showed 1 increment. That gap is the third proof point. Autosave churn. We forced keystroke-level edits for 2 minutes with autosave on, then paused. UAL spiked. Version history produced 1 or 2 increments, not dozens. Acceptable by design, significant for expectations. We captured the time between the last keystroke and the version appearance. The batching window mattered. That's the fourth proof point. We checked preservation hold library behavior to ensure we weren't losing versions silently. We deleted one of the burst files under retention immediately after the session. The PHL stored a preserved copy with all prior versions consolidated as the preserved artifact, consistent with the post-2022 behavior change. It did not create additional versions for each rapid edit. It preserved the latest known structure and the version history that already existed. No hidden reservoir of micro-versions appeared. That's the fifth proof point. We examined storage metrics for the library. If version suppression were silently discarding significant states, storage growth might betray it. Instead, we saw expected growth for Office files under heavy edit. The growth mapped closer to content delta size than to file modified counts. Storage told us nothing new about version count. It confirmed that consolidation didn't imply data loss beyond intentional coalescence. Sixth proof point, storage growth without proportional version growth. We ran a control with autosave off, single author, 5-minute gaps between meaningful edits, save after each. Version increments matched edits within one. The ratio improved dramatically. Creation compression faded when we removed co-authoring and reduced temporal proximity. The system behaved like traditional versioning. Seventh proof point, the compression is contextual, not universal. We verified UI signals. The version history pane occasionally displayed saved by autosave entries that bundled multiple content changes. We clicked through details. The Delta preview showed multiple paragraph updates within one version. We confirmed authorship attribution remained accurate. We confirmed timestamps were precise to the minute, sometimes the second, but not per keystroke. Eighth proof point, the UI itself admits consolidation. We validated discovery impact. We ran eDiscovery queries filtering by version metadata and date ranges. Premium review sets preserve item states at the time of collection, but they don't explode autosave microstates into discrete discoverable versions. The collected item corresponds to available version entries. If those entries are compressed, discovery inherits the consolidation. Ninth proof point, search consistency doesn't equal scope consistency when creation compresses variants upstream. Here's what this proves. Activity does not equal version persistence. Intelligent versioning and co-authoring produce fewer preserved versions than naive expectations underload, even when everything is green. The policy didn't fail. The object changed at creation, so we ran it again, not to chase more edge cases, but to accept the behavior and reframe the implication. If your governance assumes every meaningful edit becomes a distinct recoverable state for a near-term window, your assumption is wrong under autosave and co-authoring. Your retention promises hold the versions that exist, not the edits that occurred. We closed the loop with one actionable measurement, instrument version velocity against file modified velocity as a routine signal. Track the ratio per hotspot library. When the ratio drifts flatter over time without a change in collaboration pattern, you're seeing creation behavior change. Not a failure, a meaning shift. Loop 1. Realization. The object changed. The policy didn't fail. The object changed. Creation under autosave and co-authoring produced fewer preserved states than our mental model. The tenant stayed green. The behavior moved. We reconciled what that means. The library is still compliant. The label still applies. The retention policy still retains. But the artifact pool is smaller than assumed at the moment history matters most. Immediately after work happens, we measured it. Single author spaced saves near 1-to-1. Co-authoring autosave on 5 or 6 modifications per version. That's not an error. That's consolidation. So we ran it again. We asked a narrower question. What does a project owner actually have when they say roll back to the copy from 10 minutes ago? In the compressed run, the closest recoverable state might be a merged version that includes multiple edits across authors. The request is reasonable. The system returns a different answer, a safe, consolidated state, not every branch. The difference matters. That's when we realized stability without variance is telling us filtration, not control. The dashboards were flat, the logs were clean. The version pane said saved by autosave. The behavior had changed. Only later did we realize how this propagates downstream. Discovery inherits what exists. If creation collapses adjacent edits, your review set contains fewer granular states. If your reconstruction relies on micro steps, they might not be there. The policy kept what the platform considered meaningful. Our question assumed a finer mesh, so we reframed action in operational terms. First, monitor version velocity versus edit volume in hotspots. The ratio is a signal. If your collaboration pattern is stable and the ratio flattens further, creation behavior moved again. Treat it as drift, not failure. Second, surface expectations. Document that co-authoring plus autosave compresses near-term history. Publish recovery guidance that uses realistic version spacing. Avoid promising one-to-one rollbacks unless your process enforces spaced saves. Third, test recovery under load quarterly. Pick a representative library, replay a timed edit burst, and validate that your restoration runbook finds what stakeholders expect. If the gap widens, record it as a baseline shift. Fourth, align retention intent with reality. A retain then delete label preserves versions, not edits. If specific workflows demand granular checkpoints, build process controls, manual save cadence, single author windows, or approvals into the work, not the policy. We closed the loop with one sentence for ourselves. The object we retain is the versioned artifact, not the lived sequence of edits. In this tenant today, that artifact exists at a coarser resolution under load, so we ran it again. Different question, same tenant, not about creation anymore, about survival. Loop 2, statement of question, survival. This loop isn't about policy, it's about survival. We kept the same retention policies, the same labels, the same sites. So we changed the stressor, storage pressure, and cleanup cadence. We asked, what remains long enough to meet governance when low-priority artifacts are removed earlier by operational forces? Expectation stated plainly, retention prevents loss until expiry. If retention is in scope, content should be preserved, even if users delete it. But SharePoint and OneDrive operate in a living system. Storage quotas, meeting recordings, large binary formats, and site hygiene jobs exert gravity. We want to see what disappears before governance intersects, so we ran it again. We picked a team site that ingests frequent large files, design assets, test exports, meeting recordings synced from channel meetings. We tracked storage metrics daily. We confirmed no priority cleanup policies were active. We verified that standard recycle behavior and the 93-day window were intact. We logged UL events for deletions and size deltas. We left retention holds off to observe the baseline current. Then we started a simple routine: create, upload, minor change, and delete low-value variants while preserving high-value primaries. Observation arrived quietly. Some low-priority items vanished from user view on schedule. That was expected, the recycle bin collected them. But the timing of operational cleanups in adjacent areas, the meeting recording folders, the personal OneDrive spillover for temporary work, meant certain items never aged long enough to be meaningful in corpus growth. They were created and removed well before any review or governance policy made them matter to discovery or to business memory. They survived less than the attention window. We controlled for error. We checked the PHL for the site after the first delete under retention for a labeled library. Preserved copies existed where retention applied, but outside labeled scopes or where labels were auto-applied with delays, pre-governance deletions reduced the visible set. The policy did not fail. The item never lived where the policy could observe it long enough to matter. We slowed the cadence. We extended the lifespan of temporary files to a week. We repeated. Survival improved. More items intersected retention. The PHL footprint grew, but the pattern held. Anything routinely created and removed inside smaller operational windows contributed noise to activity and zero to governance outcomes. Our dashboard stayed green. Our corpus stayed deceptively lean. So we widened the lens to storage pressure. We watched OneDrive sites nearing quota, where users were prompted to clean up. We saw manual purges and sync client behaviors remove temporary data fast. In sites with active housekeeping habits, low-priority artifacts were gone in hours or days. Retention labels applied to designated libraries worked. Unlabeled areas were transient. Now, this is important because survival happens before governance. If cleanup, manual or automated, user or operational, occurs before retention applies, governance measures success on a reduced set. You can't retain what no longer exists long enough to be retained. We marked action. Map pre-governance deletion zones. recordings, temp exports, cache-like libraries. Measure hit rates for retention in those zones. If the hit rate is low, either extend lifespan until retention intersects, or move the content into governed locations by default. Then monitor the variance. If survival declines, expect discovery flatlines even as activity climbs. So we ran it again. Same tenant, same policies. Next loop, evidence. Loop 2, evidence pre-governance cleanup. We needed proof that survival happens before governance, so we ran it again. First, we reconciled purview definitions against what we were watching. The policy text was clear. Retain then delete on scoped libraries. Labels auto-applied where queries matched. No preservation lock. Priority cleanup was not enabled. That's when we realized definitions alone don't describe execution order. Cleanup jobs, user purges, and app-specific life cycles can act earlier. We had to correlate events, not rely on policy text. So we instrumented approval and simulation paths without turning them on. We drafted a priority cleanup scope for recordings and temp export libraries, then stopped at simulation. The simulation previewed matches. It showed exactly the classes of files we already saw disappearing under user cleanup pressure. No action executed. The preview gave us a target set to watch. The outcome was correct, so we ran it again. We pinned audit event sequences, unified audit log queries, filtered for file uploaded, file modified, file deleted, plus SharePoint file operation for recycle transitions. We added Teams meeting artifacts. Stream video creates for channel meetings that now land in SharePoint. We synchronized these with storage metrics deltas. The pattern emerged. Upload events for large files clustered around meetings. Deletes followed hours later. Recycle bin events logged. No retention hold in those recording folders. The lifecycle completed inside a 1 to 3 day window. Now this is important because the retention label auto-apply policy had its own cadence. Up to 7 days for policy distribution. Background scanner cycles to stamp items. Even auto-apply can arrive too late for quick-lived artifacts. We verified by listing item properties for a recording kept intentionally for 5 days. The label appeared on day 3. For recordings purged by day 2, no label ever applied. Governance measured green on the items it saw. The set excluded most recordings. So we moved to storage metrics. For the site's recordings and temp exports folders, we plotted size over 2 weeks. The curve spiked after meeting heavy days, then flattened within 48 hours as users cleaned up. Libraries under labeled scope had slower stair-step declines, reflecting PHL copies and recycle retention. Unlabeled areas returned to baseline quickly. We reconciled counts. The dip preceded any retention action. Survival ended before governance started. That's when we realized our green reports were sampling the quiet horizon after the tide receded. We needed to isolate eDiscovery's perspective, so we ran weekly identical KQL across identical custodians. Names, paths, and a date window covering the meetings. Execution times stayed flat. Result counts stabilized, ignoring the weekly surge of temp content. Not a bug, a scope artifact. Custodian scoping didn't include the channel's SharePoint location for recordings. Even after we added it, the files that vanished in 2 days rarely intersected the query because they were gone by collection day. Search consistency wasn't proof of scope consistency. We documented it. Next, we verified preservation hold library behavior in mixed zones. We performed a controlled delete in a labeled library adjacent to the unlabeled recordings folder. The PHL received the preserved copy. In the recordings folder, a user-initiated delete sent the file to first stage recycle, then on towards second stage, without PHL, because no label or site policy covered that folder. 2 neighboring zones, different survival paths, same tenant. The outcome was correct. We examined approval workflows and audit events to see if no violation logged meant no problem. It did. Governance saw less because the environment produced less that intersected governance. There was nothing to alert on. Compliance manager stayed green. The dashboards were flat. The logs were clean. The behavior had changed. The system's silence was a byproduct of filtration by timing. Edge cases confirmed it. OneDrive spillover. Users exported test data to personal work areas, ran minor manipulations, and cleared them before week's end. The retention policies covering OneDrive applied to all accounts, but auto-apply labels lagged. PHL appeared only after the first delete under retention, and for fast rotations, that first delete happened before policies even evaluated. We reconciled mailbox notifications to users about nearing quotas. Cleanup behavior increased immediately after prompts. The corpus thinned where governance hadn't yet looked. We validated that holds versus cleanup precedence wasn't the issue here because we deliberately avoided holds in this loop. Holds would have changed outcomes. Our point was simpler. When survival windows are shorter than governance clocks, retention success does not equal data survival. We repeated the test with a simple admin approval gate for simulated cleanup. Nothing executed. Still, users removed items faster than governance observed them. Simulation told us what would be targeted. User behavior showed what was already gone. We plotted a simple matrix: location type, label presence, average lifespan, policy propagation age, and discovery inclusion. Labeled library with stable content. Lifespan exceeded propagation, retained, and discoverable. Unlabeled recordings. Short lifespan, under propagation window, often absent from discovery. Temp exports, lifespan variable, frequently under 3 days, low discovery hit rate. OneDrive transient work, under a week, label arrival inconsistent, survivability low. Proof checkpoint. This proves retention success does not equal data survival. The policy didn't fail, the artifacts didn't persist long enough to be governed, and discovery inherited a leaner corpus. When everything is green after cleanup, we measured repetition, not reality. So we ran it again, armed with a constraint: extend the survival window or move the content into governed scopes at birth. Then remeasure. Storage metrics deltas should linger, PHL footprints should grow proportionally, and eDiscovery counts should reflect the previously missing classes. If they don't, stability is still filtration. The outcome was correct, the behavior had changed. Loop 2, realization: you can't retain what's gone. You can't retain what no longer exists. The policy didn't fail. The artifacts evaporated before the policy could see them. That's not a permission story. That's an order of operations story. The tenant stayed green. The outcome was correct. So we ran it again. We reread the acceptance criteria we set earlier and marked the hidden dependencies. Retention assumes time. Discovery assumes presence. Cleanup, human or automated, erases both. We realized our success measurements were taken after reduction. Post-reduction success looks like control, but it's filtration. That's when we realized stability was a symptom. Quiet dashboards didn't mean a quiet system. They meant a smaller corpus. We weren't enforcing. We were measuring what survived the churn. So we turned realization into procedure. First, we separated governance clocks from survival clocks. We listed each mechanism with its cadence: retention, policy propagation up to 7 days, auto-apply label evaluation on background cycles, PHL creation on first relevant delete or edit, recycle bins at 93 days. Then we listed operational clocks: user cleanup within hours, meeting recording purges within days, OneDrive quota prompts causing same-day deletions. The overlap was thin. That gap is where preservation loses. Second, we reframed green. On success means the engine is available, not that it intersected the data we care about. We annotated each success with a coverage note: governed locations versus ungoverned, long-lived artifacts versus short-lived. We stopped accepting generic compliance percentages. We asked which classes of content drove this score. Third, we traced pre-governance deletion like an incident. We treated every quick-lived class as if it were a near miss. We wrote a brief for recordings, temp exports, and OneDrive tinkering: location, average lifespan, label arrival timing, evidence of discovery inclusion. We published it to the stakeholders who thought retention was universal. Fourth, we defined a triage decision. If the business needs these artifacts discoverable or restorable, change the birth location or lengthen the survival window. If not, accept that they will never enter governance and document that reality. No more implied promises about everything is retained. We then set actionables we could test without building new tools. Instrument a simple survival hit rate: percent of items in a target location that receive a retention label before deletion. Track weekly. If it trends down, governance is drifting away from activity. Audit the classes that never reach retention. Execute UAL-based counts versus label presence for recordings and temp exports. If label presence remains low, either move creation into labeled scopes or enforce minimum lifespan. Publish an internal standard: For content types with compliance expectations, either ensure governed locations at creation or require a minimum holding period that exceeds label evaluation cycles. Add a reconciliation step to discovery. When counts are flat, compare against UL activity for the same custodial scope. If activity rises while discovery stays flat, assume survival loss and investigate order of operations. We wrote one quiet directive for ourselves. Cleanup is continuous. Retention is periodic. If survival ends before governance starts, compliance success is sampling the quiet. So we ran it again with a single variable changed. We forced recordings to land in a labeled library, the label applied at birth. The PHL appeared on first delete. Weekly discovery saw them before users removed them. Counts rose, then declined along a governed path. The dashboard was still green. This time the green described behavior, not aftermath. We closed the loop with a constraint we can verify. If pre-governance deletion is a class behavior, then reducing it should raise discovery counts, PHL footprints, and storage metrics dwell time in that class. If those don't move after we change the birth location or lifespan, the filtration moved somewhere else. That's the drift to chase next. So we ran it again. Same tenant, same policies, different question. What does discovery think it's seeing? Loop 3, statement of question, discovery. This time the question is discovery itself. We kept identical KQL, we kept the same custodians. The tenant's data grew. Our expectation, execution time and result counts should scale with growth, or we should be able to explain any countervailing scope filters. If the numbers stay flat without cause, discovery is inheriting a reduced corpus from creation and survival. So we ran it again. We opened the same case. We duplicated last week's search and left every field unchanged. Keywords, paths, date range, custodians. We triggered statistics first. The processing graph drew a familiar shape. Time to first estimate, steady. Total hits close to last week. The tenant added content, but our counts didn't reflect it. Not zero change, just stabilized sets that ignored the visible activity we saw in the logs. We controlled for the obvious. We verified advanced indexing wasn't still chewing on partially indexed items. The case showed no pending flags. We spot-checked new content created during the week. Items were fully indexed. We didn't see partially indexed warnings. The outcome was correct, so we ran it again with a widened scope. We added the SharePoint locations we knew housed the transient classes, recordings, exports. Execution time stayed flat. Counts barely moved. When we sampled the hits, we saw older items that had survived previous windows. The fresh search was absent. That's when we realized discovery was faithfully searching what existed now, not what existed then. Stability reflected survival's filtration. We narrowed the lens next. We built a search scoped only to the burst library from loop 1. We expected a gentle increase because we created and kept specific files. Counts rose by exactly the number of items we retained. None of the quick-lived variants that never received labels appeared. Search consistency was intact. Scope consistency depended on upstream behavior. We planted a small micro-story. Last week, someone asked why their weekly legal search never picked up meeting recordings that clearly happened. We showed them the survival matrix and the order of operations clocks. When we rehomed recordings into governed locations, their next run included them. That's the power of aligning discovery with creation and survival. We added a procedural dial. We exported items reports for the search, sorted by location and created date, and compared to UAL counts for uploads in the same custodial window. The ratio, discoverable items to created items, held steady for governed libraries and wandered for transient zones. We wrote it down as a discovery coverage ratio. We will track it. We asked the second discovery question. Does execution time track scope growth? We logged execution profiles for the same KQL over 4 weeks. The durations varied within a narrow band, even when the tenant added many items. We cross-checked with statistics on data sizes. Review sets and exports finished in the expected windows. The system was fast. It just wasn't broad when the corpus shrank upstream. That's when we realized we were using performance stability as a comfort signal. It was a scope signal in disguise. We documented one more constraint. Premium review sets capture items as they exist at collection time. They don't invent compressed micro states that never became versions. If Loop 1's consolidation created coarser versions, Loop 3's review sets inherit those coarser states. If Loop 2's survival ended early, Loop 3's collection never sees it. Discovery is the mirror. It reflects what the platform considers real. Our job is to align that reality with intent. We close the statement with our working test. For any recurring search, track 3 numbers: upload activity for the scope window, the discovery coverage ratio, and execution duration. If activity rises while coverage stays flat and duration holds steady, discovery is stable because scope is quietly narrower. That's not failure, that's the inherited meaning from creation and survival. So we run it again. Same KQL, same custodians. This time we expect the next loop to show us the evidence in discovery's scope drift. Loop 3, evidence, scope drift in discovery. So we ran it again. We reconstructed the case history. Identical KQL. Identical custodians, 4 weekly executions captured and archived. The processing profiles looked the same. Indexing complete. Statistics populated. No partial items flagged. The outcome was correct. That's when we realized the profile sameness wasn't comfort, it was a clue. We replayed the searches side by side and added one instrument, a data source ledger. For each run, we enumerated locations, mailboxes, OneDrive accounts, SharePoint sites, Teams-connected libraries, then mapped which subsets actually returned hits. Week 1, the ledger flagged 8 locations with results. Week 4, with the same scope, declared the hits concentrated into 5. The locations were still in scope. They just didn't contribute. Survival had thinned them before we arrived. Discovery didn't drift on its own. Its effective scope had narrowed through upstream behavior. We validated with statistics versus exports. Statistics told us items matched. Exports told us what items survived the path to review. We compared counts, statistics 1,274, export 1,271. That delta was noise, but the per location breakdown showed the drift. The 3 disappearing locations delivered 0 items in week 4, not because search failed, but because the corpus in those locations self-minimized through creation compression and pre-governance cleanup. We reconciled with Audit. UAL showed weekly file uploaded bursts in those locations. Discovery's hit maps ignored them a few days later. The timing closed the loop. We turned on advanced indexing awareness. Premium cases handle partially indexed items automatically during search, review set add, or export. We forced a run with the include partially indexed toggle to verify there wasn't hidden backlog. Counts moved by low single digits, not enough to change the story. Advanced indexing didn't rescue content that never existed by the time we queried. It confirmed the platform was caught up. The outcome was correct. We scrutinized review set behavior. We added the weekly results to a rolling review set, then applied analytics, near duplicates, email threading, and clustering. The reductions were normal, but the item universe feeding the review set reflected the same narrowing, fewer sources contributing even as overall tenant activity climbed. We tagged items by location and age at collection. Items from governed libraries skewed younger. Items from transient zones skewed older, because only the occasional outlier survived long enough to be collected. That's scope drift in practical terms. Discovery sees what persists, not what occurred. Custodian scoping next, we confirmed the custodians hadn't changed. We then expanded to frequent collaborators as a sanity check, a premium feature that maps adjacency around custodians. The collaborator cloud grew over 4 weeks, but the added nodes brought little incremental content into the set. Why? The collaborators worked heavily in transient areas. Their contributions evaporated before the weekly collection. We saved that map. It looked like reach. It behaved like loss. Team's artifacts needed their own pass. We added team and channel locations explicitly, including the SharePoint folders that store channel files and the recordings library where we had adjusted the birth location in a subset. Where we rehomed recordings into labeled governed locations, Discovery picked them up reliably. Where we left the defaults, 2 patterns emerged. Items older than our weekly cadence sometimes appeared, but the weekly surge did not. Scope drift wasn't uniform. It traced configuration choices. We then sliced by deleted and trimmed content behavior. We tested version handling impacts by querying for items with multiple versions within the date window using metadata filters. The subset that rose into the review set represented consolidated versions from the creation loop. Discovery did not reflect microsteps, it reflected the version grain we had. That confirmed inheritance from loop 1. Search consistency does not equal scope consistency where creation compresses state. We introduced a control, a static site used for policy documents, with strict single-author edit windows and enforced manual saves. No autosave churn, no quick deletes. Weekly discovery counts from that site increased linearly with content additions. Execution times for the overall KQL increased marginally when we added that site's growth. Everywhere else, time was flat because effective scope was thin. Performance stability mapped to stability in effective scope, not tenant growth. We went back to the items reports. We added 2 computed fields, created to collected latency and location survival class. Governed transient spillover. Latency clustered under 3 days for governed sites, clustered at NA for transient because most items never arrived. We charted the discovery coverage ratio over 4 weeks. Governed 82, 83, 81, 84. Transient 21, 18, 19, 17. The ratio trended down in transient zones as user cleanup accelerated with quota prompts. That's measurable scope drift. We stress tested by widening date ranges retroactively. We pulled a month instead of a week, then another month offset. Longer windows increased counts, but they backfilled only what survived longer than survival clocks. The weekly surge signature still didn't appear in the recent window. Discovery wasn't wrong, it was punctual. Our cadence was the variable. We concluded with the proof checkpoint. This demonstrates that Discovery's steady counts and flat execution profiles indicate a narrowing, effective scope, inherited from creation consolidation and pre-governance cleanup. Search consistency, scope consistency. The outcome is correct. The behavior has changed. So we ran it one more time with one visible intervention. Relocate transient classes into governed locations at birth for half the sample. The next week, statistics rose in those locations. Exports matched, review set analytics reflected the surge, and execution time ticked up slightly. The green stayed green. This time, stability described coverage we could explain. The pattern, creation, survival, discovery, nothing failed. The outcome was correct. So we replayed the whole run as one system, not 3 loops. Creation, then survival, then discovery. Same tenant, same policies. The meaning changed in sequence. Creation compressed. We observed it. Co-authoring and autosave bundled near-term edits into fewer preserved states. The library was compliant. The artifact pool was smaller than we assumed while the work was fresh. That's creation's behavior. Survival shortened. We measured it. Quick-lived classes, recordings, temp exports, OneDrive spillover often vanished inside operational windows that were shorter than governance clocks. Retention success registered on what remained. That's survival's behavior. Discovery stabilized, we documented it, searches ran fast, counts stayed flat, and review sets filled from locations where artifacts persisted long enough to be collected. That's discovery's behavior. That's when we realized we were watching a single pattern. Intelligent versioning creates fewer near-term states, operational cleanup removes low-priority artifacts early, and discovery faithfully reflects the smaller corpus that survives. Stability indicated systemic filtration, not control, so we ran it again with linkages explicit. Creation to survival first. Intelligent versioning's consolidation produces a coarser set of versions at birth. When those items live in zones with short lifespans, there are fewer preserved states to begin with, and less time for retention labels to arrive. The PHL mirrors whatever exists at deletion time. It doesn't backfill micro states that never became versions. The result, a preserved record of consolidated versions for a subset of items that lived long enough, and nothing for the ones that didn't. Survival to discovery next. Cleanup, user-driven or operational, happens continuously. Governance clocks tick periodically. Anything deleted before label evaluation or outside governed scopes never contributes to discovery's counts. Weekly searches look identical because they are searching what persists, not what occurred. Execution time stays flat because effective scope thins while tenant activity rises. Creation to discovery as an echo. Premium review sets collect versions, not keystrokes. If creation compresses, review sets inherit that grain. If a stakeholder expects a 10 minutes ago rollback to represent every branch, the answer they receive is the merged checkpoint the platform regarded as meaningful. Discovery is not wrong, it is punctual and literal. So we wrote the pattern in operational language. Intelligent versioning yields fewer near-term versions under co-authoring and autosave. This is by design. It is not a failure state. Priority cleanup isn't required to reduce the corpus. Ordinary user behavior and storage prompts remove transient classes before governance clocks intersect. eDiscovery returns consistent results within its scope. Scope effectiveness is a function of what survived creation and survival, not what was created. That's when we realized our green posture was a closed loop. Compliance manager stayed green. Secure score stayed steady. UAL was clean. None of those signals described the behavioral chain from creation to survival to discovery. They confirmed policy availability and correct execution on the reduced set. In retrospect, we had treated stability as proof when it was a symptom. Flat dashboards in a growing tenant didn't indicate control. They indicated filtration had become predictable. We needed a way to hear the pattern early, so we stitched together 3 low-friction signals: creation ratio, version increments to file modified velocity per hotspot library, track it weekly. Under stable collaboration, a flattening ratio signals more aggressive consolidation or changing save cadence. That's the creation dial. Survival hit rate, percentage of items receiving a retention label before deletion in transient zones. If it drops, governance clocks are losing to operational clocks. That's the survival dial. Discovery coverage ratio, discoverable items to created items for recurring scopes, reconciled against UL uploads. If activity rises and coverage stays flat, discovery is faithful to a thinner corpus. That's the discovery dial. We replayed the system with one change at a time to validate causality. We enforced spaced saves on a critical library for a week. Manual saves after paragraph level changes, no co-authoring during approvals. The creation ratio tightened. More versions appeared. Downstream, the discovery coverage ratio for that library improved slightly. There were more version states to collect. The outcome was correct. We rehomed recordings into governed locations at birth. The survival hit rate rose. Labels applied immediately. PHL footprints grew on deletes. 1 week later, discovery counts for the recordings class increased, and execution time ticked up. The behavior was measurable. We widened custodian scope only after the upstream fixes. Without addressing creation and survival, expanding discovery locations added little. After we moved birth locations and slowed deletion, the same expansion produced a visible count increase. Order mattered, so we wrote a compact replay rule: fix creation granularity where it matters, extend survival windows or govern at birth for transient classes, then validate discovery coverage ratios. If discovery remains flat after upstream changes, either governance clocks still lag or filtration moved elsewhere. That's when we realized the sentence we'd carry forward. The outcome was correct. The behavior had changed. Stability wasn't proof of control. It was the symptom of a system optimizing for fewer, faster, cleaner answers. We closed the pattern by restating intent clearly. Governance assures what exists and persists. Not everything that briefly appears and changes. If your results never change, measure the chain. Creation compresses, survival reduces, discovery reflects. If stability persists after upstream dials are adjusted, you are auditing repetition, not reality. So we ran it again. This time we would confront the lie directly. Execution equals intent. The lie, execution equals intent. The same policy executed again. The outcome was correct. That's where the lie hides. We equated execution with intent. We measured that a rule ran, therefore our purpose was enforced. The platform complied. Therefore our governance worked. That's when we realized we had been grading process, not meaning. State the lie plainly. Executed policy equals enforced intent. It doesn't. Execution proves availability, not interpretation. The system did what it's designed to do. It didn't necessarily do what we thought we asked. Here's how it manifests. Retain all versions, we say in shorthand. What we actually get under autosave and co-authoring is fewer near-term versions by design, with trimming schedules that honor the current version and thin old ones later. The policy didn't fail. We misread the object it protects. We retained versions, not edits. That gap is meaning, not malfunction. Another manifestation, discovery completeness. We run identical KQL. We see steady counts. We conclude scope is stable. But the corpus upstream has already filtered. Creation collapsed microstates. Survival removed short-lived artifacts before labels arrived. Discovery returns consistent answers inside a shrinking set. Consistency isn't completeness. We validated that the engine runs. We didn't validate that our intent, find what happened, was satisfied. We felt this most in the flat dashboards. Compliance manager stayed green. Secure score remained steady. The unified audit log was clean. Remember how convincing that green felt? It rewarded us for asking whether the machine was on, not whether it was describing the behavior accurately over time. So we reframed validation, velocity versus growth versus execution profiling. 3 lenses, 1 question. Do our measurements reflect the tenant's behavior or only the system's repetition? Velocity first. Version velocity to file modified velocity at hotspots. If edits accelerate and versions don't, creation is compressing more aggressively or save cadence changed. That's not a failure, it's a meaning shift. If we ignore the ratio, we will claim retained versions as intent fulfilled while the historical resolution stakeholders expect has drifted. Growth next. Storage metrics, PHL footprints, and labeled item counts by class. If activity rises and these don't move in tandem for transient zones we care about, survival is ending before governance begins. Policy on success isn't intent enforced. It's a pump idling against a closed valve. Execution profiling last. eDiscovery execution time, statistics, and location contribution over time. If the tenant grows and profiles stay flat while location contribution consolidates, discovery is faithfully searching less. Search ran is not scope aligned with business questions. We proved this with the coverage ratio. It didn't change when we tuned discovery alone. It moved only after we changed creation granularity and survival windows. We wrote our quiet directive. We measured repetition, not reality. We looked for steady lights and got them. We didn't instrument variance. We didn't track drift. So we brought the lie down to procedures we can audit. Replace policy executed with policy intersected. Log the percent of target class items that received a label before deletion. Treat dips as incidents. The outcome can be correct while intent is unserved. Replace retained versions with recoverable checkpoints within expected resolution. For workflows that require 10-minute rollbacks, test under co-authoring and autosave. If the creation ratio flattens, publish the constraint. Execution remains correct. Your promise must change. Replace discovery stable with discovery coverage ratio aligned to activity. Reconcile weekly uploads to weekly discoverables for recurring scopes. If upload velocity rises while coverage stays flat, assume inherited filtration. Don't widen KQL first. Fix upstream births and lifespans, then remeasure. Replace green score with green annotated. For every on success, add the class and location coverage notes. If the green excludes recordings, temp exports, or OneDrive spillover that matter, write it down. Treat ungoverned births as a decision, not a hidden default. We accepted one more constraint. The platform will continue to optimize. Intelligent versioning improves storage. Autosave improves collaboration. Cleanup improves user experience under quotas. eDiscovery improves throughput. None of these are errors. They are optimizations that trade granularity and dwell time for efficiency. Intent enforcement requires us to recognize the trades and adjust process, not blame the tools. So we confronted the lie where it was most comfortable, in unchanged charts. If the chart doesn't move when the tenant moves, it's not describing intent, it's describing repetition. We wrote the sentence on the wall where we stage our runs. If your results never change, you're governing repetition, not reality. Then we ran the baseline again with new eyes. We stopped asking if the policy executed. We started asking whether the behavior we care about is visible at the resolution we promised, long enough to be governed and discoverable on the cadence we claimed. The outcome remained correct. Our understanding changed. That was the point. Break the loop. Variance over success. Nothing failed. The outcome was correct, so we stop congratulating repetition and start auditing variance. We flip the objective. Success is no longer green. Success is measured drift we can explain. Flat is an incident until proven otherwise. First, we audit the repetition itself. We treat flatness as an anomaly. If a hotspot library shows the same version to modification ratio for 6 weeks while collaboration patterns change, we don't celebrate predictability. We open a ticket. The same search executes in the same time with the same results while tenant activity rises. That's not performance, that's scope starvation. We log it, so we ran it again with variance instruments. Creation variance. For each hotspot library, we compute version velocity divided by file modified velocity and track it weekly. We expect natural oscillation around a baseline tied to workflow reality. If the ratio flattens down without a change in authorship pattern, autosave policy or save cadence behavior shifted. We don't guess, we replay a short burst with spaced saves to calibrate. If the ratio rebounds in calibration but remains flat in production, we know consolidation is increasing under load. That's a finding. Survival variance. We instrument retention, hit variance, percent of items receiving a label before deletion, computed per class, recordings, temp exports, OneDrive spillover. Expectation, this number is noisy but bounded. If it drops steadily, survival clocks are beating governance clocks. We test a constraint. Rehome a subset at birth into governed locations. The hit rate should rise. If it doesn't, propagation or labeling logic lags further than expected. That's drift discovery variance. We track execution time, statistics, and the discovery coverage ratio, discoverables to created per recurring scope. We expect duration to rise with scope when upstream behavior preserves more. If duration and counts stay flat while upload velocity rises, discovery is searching less, not faster. We widen only after upstream dials change. If widening alone moves little, we revert and fix creation and survival first. But here's where it gets interesting. Variance demands comparisons, not snapshots. So we add deltas. We compare week-over-week version velocity ratios for the same library against co-authoring percentage and average save spacing. If the ratio flattens while co-authoring rises and saves cluster, causality lines up. If the ratio flattens without collaboration change, we look for tenant-wide versioning toggles or client updates. We reconcile change records. No change logged plus behavior change equals drift. We compare survival hit variance against storage metrics dwell time. If labels arrive earlier but dwell time still shortens, cleanup move to a new vector, quota prompts, new UX nudges, or app updates. We don't guess intent. We measure before and after prompts. If deletion events spike within hours of prompts, we annotate the driver and adjust governance clocks or birth locations accordingly. We compare discovery coverage ratio against weekly upload velocity for the same custodial scope. If velocity climbs and coverage stays flat, we validate that advanced indexing shows no backlog. If indexing is clear, scope is simply thinner. We log it as inherited filtration. Only after we alter upstream births do we expect the ratio to rise. If it stays flat, we miss the birth path. Now we need stress tests. Variance without pressure tells us little, so we stress test discovery. We run the same KQL after rehoming half the transient class to governed locations at birth. Execution time should tick up. Statistics should increase. Exports should match within noise. Review set analytics should show new clusters by location and age. If those dials don't move, our rehome failed or the class still dies before label arrival. We adjust, then we run it again. We stress test creation. We enforce spaced saves and single author windows during approvals in one critical library for 7 days. Version velocity should rise. Restore exercises should produce finer checkpoints. Downstream discovery coverage for that library should nudge up. If it doesn't, our recovery assumptions exceeded what versioning granularity delivers, even with spaced saves. We publish the constraint. We stress test survival. We add a minimum holding period for temp exports, 3 days before deletion. Labels should apply in time. PHL footprints should grow on deletes. Storage dwell should extend. Discovery should reflect the surge while the policy holds. If users circumvent to ungoverned spaces, UAL will show the detour. We annotate the new birth path and decide whether to govern it or block it. Metrics alone don't break loops. Procedure does, so we implement the play, treat flat dashboards as incidents until variance is explained. On success requires coverage notes. Which classes, which locations, what lifespan bands. Add 3 alerts, flattening creation ratio in hotspots, declining survival hit rates in transient classes and discovery coverage ratio, divergence from upload velocity. Run quarterly revalidation, recreate the creation burst, rehome a transient class, and replay a recurring search. Document deltas. If deltas don't appear, assume filtration moved. Integrate change management gates. Any platform toggle that touches versioning, autosave behavior, recording storage, or indexing cadence requires a before-after variance plan. No user impact means no visible failures. It says nothing about behavioral grain. One actionable first action remains. Alert on flat eDiscovery execution profiles and counts for recurring searches while upload velocity climbs. Flat is not a comfort signal, it's the earliest cheap indicator that discovery is inheriting less. We wire it to a weekly report that includes coverage notes. Then we stop restarting. We end this loop with a quiet constraint. Variance is the language the system uses to tell us what changed. If we don't instrument it, green will keep lying in fluent repetition. The playbook, break the loop checklist. Track variance, not success. We stop grading the machine and start grading behavior. Here's the checklist we execute, exactly as designed. Define acceptable drift bands. For each dial, we set a baseline and a tolerance. Creation ratio. Versions to file modified per hotspot library. Baseline taken from spaced save control runs. Drift band plus 15% over a rolling 4-week median. Survival hit rate, percent of items labeled before deletion by class, drift band plus 10 points depending on class volatility. Discovery coverage ratio, discoverables to created for recurring scopes, drift band plus 8% when upstream berths are stable. Anything outside the band opens an incident. Alerts, flat retention hits, stable eDiscovery times versus dataset growth. We wire 3 alerts. 1. Creation ratio flattening, fires when the ratio drops below the lower band without a documented collaboration change. 2. Survival hit decline fires when a class's pre-delete labeling rate trends down 2 periods consecutively. 3. Discovery flat on growth fires when execution duration and counts stay within 5% while upload velocity rises 20% or more for the same custodial scope. Alerts attach required coverage notes. No green without context. Monitor version creation versus edit volume. Co-authoring hotspots. We maintain a roster of libraries with heavy co-authoring. For each, we log weekly. Number of authors, percent of sessions with autosave on, median save spacing, and the creation ratio. If co-authoring rises and spacing tightens, a flattening ratio is explained. If co-authoring is flat and the ratio still flattens, behavior drifted. We replay a short calibration burst with manual saves to verify the metric's sensitivity. Audit artifacts that never reach retention or discovery. Quarterly, we select 2 transient classes, recordings and temp exports, and run a UAL to governance reconciliation. We count uploads, label applications, PHL entries, and discoverables. We produce a single line per class. Created X, labeled Y, preserved Z, discoverable W. If YX, ZX, or WX fall below prior quarters without a known cause, we escalate. We do not widen KQL until births and lifespans change. Simulate priority cleanup where appropriate. Confirm PHL realities. Reconcile storage deltas. We draft cleanup scopes in simulation only to preview what would be targeted, then compare against actual user deletions and storage metrics dwell time. We verify PHL presence on controlled deletes in governed zones and absence in ungoverned neighbors. We reconcile that simulation is not execution. The point is timing and class targeting, not deletion. Revalidate assumptions quarterly. Document baseline shifts. Every quarter we replay 3 controls, a creation burst with space saves, a rehome of 1 transient class to governed at birth, and a recurring discovery run with items reports. We compare against last quarter. If baselines move, we record the shift and adjust drift bands. No change is not a goal. Persistent flatness without explanation is an incident. DSC and automation. We export tenant baselines with Microsoft 365 DSC for policies that affect our dials, versioning defaults, autosave client channels, recording storage locations. We compare desired versus actual with drift-only flags. Changes to these controls require a variance plan attached to change tickets, before-after measurements for creation ratio, survival hit rate, and discovery coverage. No user impact is not accepted without numbers. Change management gates. Any toggle that can alter creation granularity, birth location, or indexing cadence carries 3 gates. Pre-change baselines captured, post-change measurements within 1 week, and a rollback plan keyed to the dials. Gate failure is defined as drift outside bands without an approved explanation. We do not rely on vendor release notes to infer no impact. Single first action, alert on flat eDiscovery execution overgrowth. We implement this now. Weekly, for every recurring KQL, we compute upload velocity for the custodial window, execution duration, statistics, and coverage ratio. If velocity rises and both duration and counts remain flat, we fire the alert with required coverage notes, which locations contributed, which did not, and whether upstream berths changed. This is the earliest cheap signal that Discovery is inheriting less. Instrument survival clocks. We chart label arrival time distributions per class against typical deletion times. If label arrival P50 exceeds deletion P50, we have a timing inversion. The play is to govern at birth or impose a minimum holding period. We test on a subset. If the inversion resolves, we scale. We write down wins and failures to reduce guesswork next time. Set ownership and cadence. Each dial has an owner. Creation ratio, content platform lead, survival hit rate, records management, discovery coverage, eDiscovery lead. Weekly reviews are 15 minutes with the 3 plots and a decision column. Observe, calibrate, intervene. No status reads without actions or no action documented. Publish constraints. We create 1 page per class and workflow that states the measured limits. Co-authoring with autosave compresses near-term versions. Expect coarse checkpoints unless spaced saves are enforced. Recordings kept under 3 days will not be labeled reliably unless governed at birth. We socialize these constraints where promises are made. Add a retrospective. When an audit or case outcome surprises a stakeholder, we run a drift review, not a blame review. We replay the 3 loops, show the dials, and reconcile where meaning diverged from execution. We adjust the playbook where our instruments were blind. We end with an operational rule. Stability requires evidence. Flat equals incident until variance is explained. We run the play. Then we run it again. The callback. Understanding beats fixing. Nothing failed. The outcome was correct. So we stop fixing the outputs and start understanding the behavior that produced them. We draw the parallel plainly. Source code investigations don't begin by patching. They begin by replaying with instrumentation. We did the same. We replayed creation, survival, and discovery with dials that describe behavior. That's when we realized our earlier successes were just reruns without observability. We restarted because the lights were green, not because the meaning held. Understanding beats fixing because the platform evolves under stable outputs. Intelligent versioning will continue to optimize. Autosave will continue to compress churn into useful states. Cleanup pressures will continue to accelerate where storage and UX demand it. eDiscovery will continue to deliver steady performance inside its declared scope. None of these are malfunctions. They are optimizations. If we don't observe the differences they introduce, our patches become rituals that satisfy repetition. So we restate the working stance. Our loop ends when interpretation changes, not when policies are reapplied. On success is an availability claim. Intersects is an evidence claim. Understanding means we ask whether the thing we promised. Recoverable checkpoints at expected resolution. Survival long enough for governance clocks to tick. Searches aligned to lived work is visible at the cadence we run. If not, we change the question we're asking the system, not the checkbox we toggle. We turn that stance into posture. Governance posture means we instrument variance. We stop grading policy execution and start grading behavioral drift. We treat flat dashboards as incidents until explained. We accept optimizations as constraints we can state, not as adversaries we must fight. We publish those constraints where promises are made. That avoids silent renegotiations with stakeholders who thought retain all versions meant infinite micro steps under co-authoring. We move from fixing to measuring meaning. That changes our cadence. Quarterly revalidation isn't ceremonial. It's a replay with controls. Spaced saves verify creation granularity. Rehoming transient births verifies survival clocks. Recurring KQL with coverage ratios verifies discovery scope. If deltas fail to appear, filtration moved. We look for it. We don't assume intent held because the policy executed. We align teams to behavior. Content platform owns the creation ratio and safe spacing constraints. Records management owns survival hit rates and label arrival distributions against deletion times. eDiscovery owns coverage ratios and execution profiles with location contribution. Weekly, they meet for 15 minutes with 3 plots and a decision column. observe, calibrate, intervene. No roll-ups without notes. We accept that understanding includes refusal. For classes of content where the business does not need discoverability or recovery, we document that they will die before governance ever sees them. We make no implied promises when we know the clocks won't meet. That is understanding in practice, an explicit negative, not a quiet hope. We add one more quiet discipline. When a result surprises a stakeholder, a missing recording, a course rollback, a flat search, we run a drift review, not a fix-it review. We replay the 3 loops with the dials. We show where creation compressed, where survival ended, where discovery reflected persistence. We update constraints or processes. We avoid inventing exceptions that contradict the system's behavior. That's when we realized we were not trying to make the system behave like our narrative. We were trying to write a narrative that matched observed behavior and could be verified on the next run. Understanding beats fixing, because correctness without meaning is the easiest state for a complex system to hold. It will obligingly repeat. So we ran it one more time and then we stopped. The outcome was correct. Our interpretation changed. The sentence that closed the loop holds: if your results never change, you're governing repetition, not reality. One sentence takeaway: if your results never change, you're governing repetition, not reality. If this reframed how you read green, subscribe, and set your first alert for flat discovery on rising activity, then watch this next episode where we instrument creation, survival, and discovery in a live tenant and reconcile variants on air.